Histograms are a special type of bar graph, and what makes them special is that the bars touch. And the reason that the bars touch in a histogram is because we have continuous data. Now, continuous data means that there's really no concrete difference. So if we talk about age, like when you go from 34 to 35, at what point do you really turn 35 then you are no longer 34? Like there's like that, there's not like a concrete split. Whereas if you're talking about like runs in a baseball game, there's a concrete difference. If somebody crosses home plate, that's one run. You have to wait until another person crosses till you get two. You don't have that like, ooh, when did I get two? You got two when they cross home plate, right? So histogram, continuous data, it's where there's no real distinction between time, age, amount of liquid, like water in a water bottle. Those things are all continuous data. So if you look at this graph is actually not 100% correct because it says, why is it appropriate for the bars to be touching? Well, you can make the argument they're not touching, but they should be. All of these bars should be a little bit wider so that they touch. There should still be a black vertical line between them so that you can see the distinction between the gray bars, but they really should be touching. And that's because we're talking about age. When you go like from 9 to 10, when is that split between 9 and 10 years old? It's continuous. Age is continuous. You can be 9.5, 9 3/4, 9.95, right? You can be all of those ages. So because it's continuous, that is why the bars can be touching. We have continuous data. Okay, so let's look at the shape of this distribution, and we can talk about shape because age is numerical. We can find the average age of people based off this. Now, this is all pretty, consistent, a little bit uniform, and then it drops down. So because the tail goes right, we would say this data is skewed right. And where are the baby boomers? Well, baby boomers are in their 50s, 60s, so they're here. They're just getting ready to start, retiring and kicking off into retirement and having a good old life. I'm not sure why that's important, but it's a question. Okay, so now we're going to kind of get into frequency distributions and creating these histograms. So a frequency distribution, the word frequency just means how many times it's there. So when you see this over here is the frequency distribution. We are given 30 pieces of data over here, and we're going to use that data to fill in our age here. Now, I notice that my youngest age is 3, so I will start with 3 and then go up by 1. We don't skip any. We want the data to be accurate all the way to 12. So I have, these are my ages, and then I have to fill in the frequencies. Now, you can do the frequencies a couple different ways. You can go through and say, there's 1 3, there's 1 3, I have 2 3s total. You can go through and count that way if you want, or you can say there's a 5, so tally. There's a 7, tally. There's another 7, tally. And you can do tallies until you add them all up and then put the total frequency like maybe on the right-hand side. It's really up to you. So go ahead and hit pause and try that. Fill it in. Get the rest of them. I'm going to fill in the frequencies for each one. Now, after you fill in the frequencies, you really should sum them up and make sure, okay, I have 30. They sum up to 30. I started with 30. Now you're good. If you happen to get the wrong number, you miss one, that's going to mess up your table. It's going to mess up all of your data. So that's something that you kind of want to avoid if possible. All right, so now we're going to make our graph based off of our frequency table. So we're going to use this table to make our graph. So you might want to, memorize this, take a picture, have it written down, whatever. But when I use this, you do have to label the axes first. So we know that we're talking about the age of carousel riders, and this represents the frequency. So frequency tells us how many. So I have 2 3s, so there's my 3s. I have 4 4, so I go up to 4. And you want to make the bars equal width if possible, but you'll notice they do touch because we're talking about age, and age is continuous. That makes this a histogram. So go ahead on your paper, go ahead and plot, finish this graph with your data. You'll notice that our 11s have a frequency of 0, so see how the graph is just down. It still connects, but it doesn't show any data. So that is my histogram, and it's a histogram because the bars all touch. Now, And number 4, when we want to find the median and the average, I want to go back and I want to show you kind of a shortcut to do all of these. Now, to find the mean, you can add up all 30 of these numbers, but I'm going to tell you, I make mistakes if I have, 30 numbers is a lot to add together. So I'm going to do it a little bit differently. If I have 2 writers at the age of 3, that's 6 total, right? Because 3 times 2 is 6. I have 4 writers that are 4 years old. That's a total of 16. 5 times 6 is 30, 6 times 7 is 42, 7 times 4 is 28, 8 times 3 is 24, 9 times 1, 10 times 2, 11 times 0 is 0, and 12 times 1. So when I add those up, I have a total of 175. That would be the same total if you would add the 30 writers here. So you might say, well, I'm not very good at multiplication. Well, you can use your calculator, and maybe you find this method to be tedious, and you'd rather just add them all together. There is no right or wrong answer. I'm just trying to give you a few other methods. So to find the average, I would take that 175, divide it by my 30 writers, and I would get an average of 5.83. Okay, which falls, somewhere in here. Okay, now let's find the median. Now, if you recall, the median is the middle number. So we put them in order least to greatest, and we work our way to the inside. Now, I want to do this again. Now that we have our graph, I'm hoping this shows okay in this graph, but when we put the numbers in order least to greatest and we take them off, we take off 1 on the small side and 1 on the large side. You can see this is 1 right here. So each one of these blocks represents one number. So if I take away 1 on the bottom, 1 on the top, I can work my way in. I want to take off 1 on the bottom. I don't have any 11s, but I have a 10, right? I have now taken care of all of my 3s. My 3s are done. I'm also done with my 12s. I'm in 10s. So I now want to take out, if I take out 1 4, I take out 1 10. My 10s are done. Then I take out another 4, and I move to the next number, which is 9. 9s are done. Then I take out another 4. I move to 8s. Take out another 4. I'm still in the 8s. Look, my 4s are done. So I move to 5s. 8. So 1 on the outside, 1 on the inside. You're moving your way to the middle. 8s are done. So I'm still in 5s. Take out a 5. I'm now moving to 7s. Still in 5, still in 7. Still in 5, still in 7. Still in 5, still in 7. 7s are done. Still in 5, move to 6s. And now you can see the only numbers I have are 6s. So I have a bunch of 6s in a row. If you move your way to the middle, you end up with 2 6s in the middle. Your median is going to be 6, because that's the bar that you're in, right? So my median is 6, which is larger than median. So we would say the mean is less than the median, which answers question 5. This is skewed left. Doesn't look skewed left, does it? It looks skewed right. But the mean is smaller than the median. That's crazy. So that is what it is. Okay? And that's kind of how you figure those. All right. So let's do another one. I would recommend you hit pause. Go ahead and hit pause, complete the frequency. So you might want to just work on this spot first. But if you look at the proportion, you have 50 numbers total. So that's why the frequency divided by the total, 1 divided by 50 is 0.02. We can change that to a percent because this is out of all customers. So go ahead and try to finish this table. All right, I had a little trouble drawing the percent sign there. It kind of got a little lumpy, so these are all percents, so this percent kind of goes with all of these. But you can see because it's out of 50, the percents all come out very, very nicely. And we can answer some questions based off this data. So you do want to double check that all of your frequencies add up to 50, and you should add up all of your percents and make sure that they add up to 100. Now, if you have to round some percentages, which will happen, it will happen from time to time. So when you round the percents, you might have to round and get close to 100, but you'll be close. So now let's go ahead and answer some questions with this. What's the mode value? So remember that mode is the most often. And if you look at your data set, you will see that 5 minutes is there 12 times, and therefore that's the mode. What's the longest someone from this study waited? Well, minutes waited, the biggest one is 9 minutes. So 9 minutes is the longest someone waited. Does this mean that nobody ever waits longer than that? Let's be serious. No, that's just in this study. So, that, I mean, 20 minutes after the study is over, somebody could wait for a half hour. You just never know. Okay, how many people from this data set waited at least 6 minutes? Now, at least 6 means 6 or more. So in our study, that's 6, 7, 8, or 9. That's who we're looking for. So when you look at that, that's these people down here. So you look at those numbers. And it says how many, so we would take the 8 plus 5 plus 4 plus 2. 19 people waited at least 6 minutes. Now, number 4, how many people, so again, how many, we're looking at numbers, from this data set didn't have to wait more than 3. So they didn't wait more than 3. That means they waited less than 3. And that less than or including, because if it says more than 3, 3 is included. So we're looking for, we're looking for 1, 2, or 3 minutes, because that's not more than 3. Right, 0, 1, or 2. So that's what we're looking for. So if you look at the top 3 frequencies, 1, 2, and 3, they had the frequencies 1, 3, 6. So add those together, we have 10 people that did not have to wait more than 3 minutes. What does the total of the frequencies represent? Well, if you look at your frequency column, you have a big old 50 there. That means all people, spelled people wrong, in the study. That's the total of the frequencies. Well, what's the total of the proportions? Well, that's 100%. And what does 100% mean? All the people, right? So the total frequency is the actual raw data, and the total of the proportions should be 100%. So it's still the same. All right, now when you get into proportion, what proportion of customers waits 5 minutes? Well, we know that 12 people waited, but that's not the question. The question is proportion. And that's where we get to the 12 over 50, the 0.24, the 24%. So what proportion? Any of those would really answer the question of what proportion. But that then leads to number 8. If you were to select a customer at random, probability. Now, probability, again, can be written as a fraction, a percent, or a decimal. For our case, we're just going to write it easy, 24%, because that's the 5-minute wait. When we go to number 9, what proportion of customer waits at least 6 minutes? Well, again, at least 6 minutes is 6 or more. And if you go back to question number 3, we know that 19 people waited at least 6 minutes. So we would take 19 over 50, which is 0.38, which is 38%. So 38% of customers waits at least 6 minutes, leading to number 10. Again, if you're going to select somebody at random, probability of waiting at least 6 minutes would be 38%. Those two kind of go together. Now, we can then make a histogram for this. Again, we're talking about minutes waited. Minutes, it's time, it's continuous data. So horizontal axis, well, that's our minutes waited. So that's 11. Is the graph symmetrical? Well, let's go ahead and make the graph. So based off frequencies, so we're using the numbers for this, not the proportions. Go ahead and I'm going to hit pause and go ahead and complete your graph. Hit pause and hit graph, and then come back and see if yours matches mine. All right, so I do this. I'm telling you what, this looks symmetrical. And is it perfect? No, but it's pretty darn close. The biggest one is in the middle, and it looks symmetrical on each side. If the graph had percentages on the y-axis, would the graph be the same or different? It would look the same because we would be dividing by the same number. And since we're dividing by the same number, that's what makes it look the same. Okay, and I really think I messed something up, and I went back and I checked, and I did. So I want to go back to actually this problem. And we talked about this. Remember when I said the mean is less than the median and it looks like it's skewed right, so that doesn't make sense? Well, that's because my top number is wrong. When I go back and I re-added this up, I get 187. So I'm not really sure what I did to get 175. I think I missed my 12. So when you take 187, divide by 30, you get 6.23, and that makes my mean bigger than my median, so it's skewed right. And so hopefully you didn't give up on this video, because I did come back and fix it. It was just eating at me that it looks skewed right, so why is my data not showing that? So when I went back and I rechecked my math, and I did make a mistake, and we do have the mean larger than the median skewed right, so the picture did lead me to go back and double check, and that's sometimes why logic helps, because your calculator's only as good as the person pushing the buttons, and if you miss a button, right, your number's going to be wrong. So that's histograms, frequency tables. Thanks for sticking with me to the end.